Most developers think they understand what happens when someone clicks login with Google. The browser redirects to Google. The user enters a password, Google redirects back. Your server receives a code, exchanges it for tokens, and the user is now inside your app. This is exactly where the confusion starts. OAuth2 does not define login. OAuth2 defines how one application gets permission to access something from another system. It is an authorization framework, not an authentication protocol. To see why, follow the flow precisely. Your application starts by sending the browser to an authorization endpoint. The request includes a client underscore ID, a redirect underscore URI, a response underscore type, a state value, and one or more scopes. The client underscore ID identifies your application to the authorization server. The redirect underscore URI tells the authorization server where it is allowed to send the browser after the user approves or denies the request. The state value lets your app match the response to the original request and protect against cross-site request forgery. The scopes describe what your app wants permission to access. Those scopes are the key detail. If your app asks for a scope like calendar read, photos, read-only, or repo, it is asking for permission. It is asking whether this client may access this resource with this level of authority. The authorization server may show a login page. That is why the flow feels like authentication. The user may have to enter a password, pass MFA, or use an existing session. But that authentication is happening between the user and the authorization server. It allows the authorization server to decide whether it can ask for consent and issue authorization. OAuth2 does not standardize what identity information your app receives from that login step. After the user approves, the authorization server redirects back to your redirect underscore URI with an authorization code. Your server then sends that code to the token endpoint. In a modern authorization code flow, it also sends the client credentials or uses PKCE, depending on the type of client. The token endpoint returns an access token. It may also return a refresh token. If this is OpenID Connect, it may return an ID token too. But in plain OAuth2, the important artifact is the access token. The access token is meant for the resource server. If the token is for the Google Calendar API, your app sends it to the Google Calendar API. If it is for the GitHub API, your app sends it to the GitHub API. The resource server validates the token and decides whether the requested API call is allowed. Your app is not the intended audience for that access token. The API is. That is the part many implementations get wrong. A developer receives an access token and thinks the user logged in, so this token identifies the user. Then they store it as the user's app session, decode it if it looks like a JWT, or build account logic around whatever user-looking field they can find. But OAuth2 does not require access tokens to be readable by the client. Access tokens can be opaque strings. Even when they are JWTs, their claims are usually designed for the resource server, not for your application. The token tells an API what access was granted. It is not by itself a login assertion for your app. This is why the same visible user experience can mean two different protocol level things. If the app only runs an OAuth2 authorization flow and receives an access token, it has permission to call an API. It has not necessarily received a standardized proof of who the user is. If the app runs an OpenID Connect flow, then it is using an identity layer built on top of OAuth2. OpenID Connect adds the OpenID scope. It adds an ID token. It defines identity claims. It defines how the client discovers provider metadata and signing keys. It defines what the client must validate. The ID token is the object your app uses for authentication. It is issued by the identity provider to your client. It has an issuer claim that identifies who issued it. It has an audience claim that should match your client_ID. It has a subject claim that identifies the authenticated user within that issuer. It has timestamps. It is signed so your app can verify that it was not forged or modified. In an OIDC login flow, your app does not authenticate the user because it got an access token. Your app authenticates the user because it validates an ID token issued to your client by a trusted issuer. Your app should check the issuer. It should check that the audience is your client. It should verify the signature using the provider's published keys. It should check expiration and timing claims. If the flow uses a nonce, it should verify that the nonce matches the value your app sent at the beginning of the flow. Only after those checks should your app create its own local session. That local session is separate from OAuth2 and OIDC. It belongs to your application. It might be a secure cookie, a server-side session, or another session mechanism. The external provider proves identity. Your app decides how to represent that authenticated user locally. This also explains why access token versus ID token is not just a naming detail. An access token answers, what can this client access? An ID token answers, which user was authenticated for this client? A refresh token answers, can this client obtain a new access token later without sending the user through the full authorization flow again? Those tokens have different audiences and different jobs. Mixing them together creates incorrect assumptions. For example, suppose your app lets users import data from an external API. You ask for an access token with a read-only scope. The user approves. Your app calls the API successfully. That proves the token works for that API. It does not automatically prove which local account should be signed in to your app. If you need to sign the person in, use OIDC and validate the ID token. Then map the issuer and subject to a local user record. A safer identity mapping is usually the combination of issuer and subject. Use OAuth2 when your application needs delegated access to an API. Use OpenID Connect when your application needs to authenticate a user. In real products, both often happen in the same flow. That is why the distinction gets blurred. A login with Google button may run an OIDC flow that also produces an access token. The user sees one button, but the protocol artifacts have separate meanings. The surprising part is that the login screen is not what makes OAuth2 authentication. The authorization server can authenticate the user as part of deciding whether to grant access. But OAuth2 itself does not standardize an identity result for your client. OIDC adds that result. So when you inspect an OAuth implementation, look at the tokens and their intended audience. If you see only an access token, ask what resource server it is for and what scopes it carries. If you see an ID token, check whether the client validates issuer, audience, signature, expiration, and nonce where required. If you see app session creation, check what verified identity signal caused that session to be created. That is how the system actually works. OAuth2 moves authorization from the user to the client so the client can call an API. OpenID Connect tells the client who authenticated. Your app creates the session after it verifies the identity information it was meant to receive. That's it.